And welcome back to day 7 of the Advent of Code 2022 in Python. Yesterday was a very short one. I did it in like 5 minutes. Today, don't know, we'll see. Okay. No space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication systems. You tried to run a system update. System update, please. Pretty please with sugar on top. Error, no space left on device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output. Okay. Oh man, we're actually using Unix commands, okay. So, the file system consists of a tree of files, plain data, and directories which contain other directories of files. The outermost directory is called /. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Oh no. We have to simulate a whole Unix system? So cd means change directory, fine. cdx moves in one level. cd ... moves out one level. cd / goes back to the top, okay. ls means a list. Yeah, okay. This looks like there's gonna be a fair bit of work. Okay. Here there are 4 directories. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Fine. To begin, find all of the directories with a total size of at most 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. Even though E is in A. That's okay, that makes sense. Yeah, fine. Okay, wow. So that's... we have to... and the input, let's have a look at the input. So basically, we're building a tree here. That's what they're getting at. We don't need to express a path to a file or directory, so we don't need to kind of tokenize. Well, alright, fine. Let's begin. So we want to so we need a tree. Each node has a name, which will either be / or one of these names. List of children, which could be files or directories, and a pointer to its parent, because we need to be able to do cd ... to go back to the parent. So we want class tree well, we don't need a tree class. We need a node class. We do kind of need a tree. Nah, we don't. Alright, so class node. So we need define the initialization of this to be... Damn it. We need name. We can't use... We can use name. Are we allowed? Because it's like a reserved keyword. That's fine. Yeah, okay, and we need a parent. Those are the two things we need. And then we will create the children. Do we want to distinguish if it's a directory or a file? Let's say is dir equals true. Well, no, is dir. Right, so if none equals an empty list, if is dir else none, just to make sure we don't try to look for children. And there we go, just get rid of that. So I guess we want to record the size. We might as well self.size size. We'll say if we don't know the size, we'll leave it as none. otherwise we record it. So only the files initially will have size. Directories won't, but then we can use recursion to populate all the size parameters. Alright, does that look right? Alright, so we say root equals, just create a new tree. No, a new node. We'll call it /. No parent is dir. Okay. Alright, that's the setup, I guess. A lot is going through my head right now. This is quite a bit more complex. Okay, let's just copy that snippet there. So we need to parse the first line. So, man. Better way to do this really is to so okay, changing directory, we just go on to the next line after we do that, but using ls, there's an unknown number of lines that will appear. So I think the better way to do this is not do this. We say okay, and let's say current equals root. So current will keep track of where we which directory we were currently looking at. So for line in, so we say line equals f.readline. Okay. So if so while we have lines, let's check. So it's either going to begin with cd or ls. That's it. Okay, so if line dot starts with so it's going to be $cd. Or better yet, let's say line equals f dot let's say args dot strip dot split. Right, so we get a bunch of args because there's always args. So if args, so the second argument is going to be cd. If args1 equals cd. Okay. So we have to handle the cases. So if it's 2, so there's 3 cases. Either it's /, then while args, then current equals root. We just go back to the root. Elif args 2 equals ... I like to use double quotes for strings and single quotes for single characters, even though Python doesn't distinguish. Alright, so they're all strings. Current equals current.parent. So we go to the parent. Simple enough. Elif else args2 is going to be a name, so is it always the case that we've run ls at least once before changing directory? Otherwise that'd be weird, wouldn't it? CMC, yeah, it was observed before we typed it. Yeah, so we can assume that will always be the case. Okay, so otherwise, for child in current.childs, if child.name is equal to args2, so that has the name we're looking for. Current equals, so we switch to that child, break out of this loop. Okay, so that handles CD. Elif args1 is, so the only other case is if it's ls. Now, sometimes you call ls and there might be nothing, right? I can't see an example, but in theory it should be possible. So let's write it as if that's the case. They might have made every folder non-empty, but you never know. There might be hidden files or something. Okay, so the other thing is I want to move to the next line. So just get the next line. Hang on. Let's say line equals f.readLine, and put this one in the while loop. So while line. So, all right. So if we've finished with CD, we just do line equals the next line. If we've done ls, we now have to check each line until we hit a new $sign. That means we've found all the files there are. So line equals f.readLine, So what are they going to look like? It's going to be... Well, okay. Let's take the arguments. While args 0 is not equal to $. So we'll keep doing this while loop until we've hit the next $. So we'll take each of these. We say, hello DJ. This one's a more interesting problem actually. This is a bit more like the sort of thing you actually do in a real programming job. We're building a... So these are Unix commands. We're given an input which is actually a bunch of Unix commands and the terminal kind of results that we get from using said commands. And we're actually parsing these and trying to build a tree of all the known folders and their contents and their file sizes. This is pretty complex actually. So, for example, so far I've programmed what happens if you type cd. So we can change directory either to the root, which is /, or to ... which means go up one level, or to a given name, in which case we have to go into the tree one level further. The only other command I need to handle is ls. So then the following lines will each display one folder or file, and I have to parse each of those and put them into the tree. So so while we have not reached a new $, we'll say current dot childs dot append. So we're going to add a new child to this node, and that's going to be a node with name. Its name is going to be the second argument. It's 1. The parent is going to be current. The isdir will be if the first argument says dir. And the size will be int of the first argument if args0 is not an integer. It is not the word dir. Else we'll say nah, because we don't know the size of the folder yet. It's recursive. Alright, that's a mouthful. And now we say just fetch the new line. So when we break out of this while loop, that means we have a $. That means we're ready for the next line. Alright, I've not tested any of this. See if it all just works in one go. Huh. How do I even test it? Yeah, I'll just run it at least, but of course it's gonna crash. List index out of range. What's the final line look like? Is it gonna be an empty line? Okay, you know what? Let's do that thing again that we do. Cheat. Take out that line. Still crashing. Oh, because it actually doesn't finish on a dollar sign. Of course. While arguments actually exists and is not a dollar sign. Okay, let's do it like that. There we go. Okay. Let's build the tree. We don't know if it's correct. Oh, man. Now, to find the size of a folder, we need to find the size of all its children. And we need to what's the phrase? Memwise this so that we keep track of the size of every folder. All right, fine. Let's say table equals an empty dictionary. Define get size of a dir. Okay, to get the size of a dir, we say size equals 0 for c in dir.childs. All right. If the child is just an ordinary node, if c dot is, if not c dot is, let's say if c dot is dir, size plus equal get size of c, so that we can call this recursively. Else size plus equal c dot size. And then table dir.name equals size, just memwise it, and then return size. Whoops. Okay, will that work? Wants me to leave gaps. All right. Built-in name. Damn it, I don't like using built-in names, even though it'll work. Alright, let's say Boulder. Alright, we're almost done. Now we just call getSize once on the root. That will just populate the table. And now we actually sum up everything. So we say total for name size in table.items if size is, so let me check we need find all the directories with a total size of at most 100,000. So if size is less than or equal to 100,000, total plus equal size. I'm not tested any of this, so node object has no attribute is dir. Oh yeah, we didn't actually make a is dir variable. We'll just use self.child. So if self.childs, if c.childs is not none, that means there's a directory. Okay, I just got some number. Let's just try it then. Damn it! Alright, first let's test this on the example input. Nine five four three seven. 95437. We got it right on the test input. That's not helpful, is it? Some of that total size. Okay, fine. So it works for the test input, but not for the this old thing. I wonder if we have our pointers current pointer set correctly at all times, because it can mess things up if we put things in the wrong place. This is all the mentions of current. So if we change directory, current goes back to root. Root node none true. We start off by changing directory to /, so yeah, that's fine. So if it's ... we go to parent. Yep, that's correct. Otherwise, we're going to child and current.childs. Child.name is equal to that. Then we go to the child and break out of that loop. Okay, that seems fine. And I fetch a new line. Ooh, I don't like how we Alright, take that out. But this is, I think it's still fine what I did there. It's just, let's put that in the while loop. Okay. So if it's ls, we fetch a new line. So, oh yeah, we do need to do this. Oh, I see why I did that. Okay, fine. Yeah, okay. Okay, we'll go back to what it was fine the way it was. So get a new line, strip it, split it. While there are arguments, and the first argument is not a $, then there are two arguments. There's going to be dir or a number. The second argument will be the name. The name doesn't even really matter, because we never actually look at the files. But fine. Populate the name anyway. Current is the parent. Yeah. Not that we even need that either. We never move the pointer to a file, only to directories. So argument 0 is dir. If argument 0 is dir, that's going to be true, otherwise false. That matches what we're looking for, yeah. And then this one is int integer of that, else none. Fine. So that looks okay. So to get the size of a folder, we do size equals 0. Yeah, okay, size equals 0 for each child. If there are children, Hang on. What are we saying here? If c.childs is not none, that means it's a folder. So we add the get size of c and recursively call get size to fetch the size. Else, that means we have a file, so we just add the size, put it into the table. Turn the size, and then we just call it on the root to populate everything. If it's less than 100,000, less than or equal to, are they going to give us a case where it's actually equal to? At most 100,000, but I'm doing that correctly. Okay. What is the sum of the total sizes of those directories? So, man, this is not easy to debug because we don't really know where we're going wrong. We got over 1 million. Right, well, let's start by printing the table, because that's kind of one of the final results we get. Alright, well, that's all the contents. And we got /, which is that, which is huge, and of course / is not going to factor in. Man, if it works on this input, that's really annoying. I can't think how to begin debugging this. I mean, I would have expected it to fail on the example inputs. So there's something about this which isn't slightly more complex than the example input they gave. They said my answer's too low, so I'm missing. Either I'm getting the wrong sizes of these directories or I'm missing some. Everything stems from the root. It's not like we have separate trees. No, okay. Oh! I know what might be the issue. If we call ls on something we've already looked at before, we shouldn't re-add those children. That might be what's happening. So my assumption was that every ls is a unique call on a directory, but they might be calling ls multiple times. So how do we address that? So we say ls. So if we've called ls before, then we need to ignore everything that we see. Alright, so we need a boolean which tells us we've seen this before. So we say is seen before. That's telling us we've seen the contents of this folder before. Equals, and that will be current dot childs not equal to empty list. So that means if we've seen it before, then there are contents there in that folder. Or it's an empty folder, but if it's an empty folder, that doesn't matter. And now we do the population, but we say if not is seen before, only then do we actually add a new child. Otherwise, we've already added that child before. Does this give us a different answer then? Damn it. Got the same answer. Ugh. I don't think they ever do that. I think they only ever check each folder once. It would have been clever. It would have been a good thing to trick us on, but yeah, they're actually walking through the tree in a kind of a proper order and not repeating. They never even use cd / again. They only use it at the once. So this is actually a proper like post order or something of the tree. Like this command here. There's exactly one. Okay, fine. So oh man, I don't know how to debug it then. All right, you know what? Let's try the example input again, but let's look at all the folders sizes. Maybe I got some of them wrong, even if they didn't count towards the final count. I hope so, because that would actually help us debug it. 95437 is the correct answer for that. 95437. So let's look at the actual. We got E584. Yeah, that's correct. A94853, that's correct. D249333642. 239 249 33642, that's correct. And / 48381165. 48381165. GP. So the very last file they show us, the very last folder they show us is RJNNZ in like the total input. And inside that is one file, and that is 258856. 258856. So, which is more than 100,000. So certainly that folder should not count towards the folders looking for RJNNZ. Shouldn't be included, right? Two 58856. I mean, that's correct. 258856 for RJNNZ. All right. What else can we do? Print. If size is less than or equal to 100,000. Am I getting these numbers right? 100,000, yeah. All right. Let's print. Name size. Those are the folders. Not many. You can actually manually check every single one of them. So we've got LNBC, PDT, JLZ, GMQ, QCC, GSS. There's no duplicates. I mean, that wouldn't happen anyway. I don't know. And the sum is 1093704. I feel like it's the right answer. Otherwise, we just have to start manually checking them. LNBC. Let's just have a look at some of them. LNBC. Directory LNBC. Change directory LNBC. LS. 62635. That is correct. That is exactly what's in LNBC. So that's correct for sure. All right, let's. Yeah, not. LS 17. Huh? Oh fuck. Oh, of course. No, that's me being stupid. Folder names are not unique. You can have multiple folders with the same name. What is unique is the path. Oh my god. Alright. So, table was a bad decision to do. Oh, that's clever. Yeah, that's my bad. I didn't think of that. But of course, you can have the same folder with the same name in multiple places. Almost done, 30 minutes later. Yeah, I made a silly error. I forgot that you can have... I mean, that's... Even to someone who doesn't know programming, it's kind of obvious. You can have a folder called My Pictures, and then you can have a folder somewhere else called My Pictures. It's not a unique name. Alright, so get rid of this stupid table, because that's assuming uniqueness. Get rid of that table. Total equals 0. This is an easy fix then. We just say get size from size. Size. And we say if so at the time when we're traversing the folders, we calculate the size of a folder. This bit is correct. It checks the sizes of children and then determines the size of the folder. We say if at that point it's 100 less than 100,000, less than or equal to 100,000. Print the name and size, whatever. Do that. Then add to the total. And then don't do anything else. No table exists. Whoa, what have I got wrong here? Size plus equal get size C. Name. What's name? Take that out. Or just print folder.name. Okay. Total. Unresolved reference total. Total's there. How is that an unresolved reference? What? Hang on. Size. Oh, because I... okay, we didn't return size at the end of the function. The function is not complete. It's still complaining about... Damn it. Cannot access local variable total where it is not associated with a value. What? Total. I've defined total. How is this not working? I must have missed a colon somewhere or something. Print. This doesn't make any sense. Somewhere there's a broken line somewhere. Alright, just take this out for now. Does this actually run? Yeah, okay. Total. Do I need to... I don't think I need to do this, do I? I thought... Okay, do that. I forget how I... Okay. Alright, we've got a number. We have a number. Good old missing colon, semicolon. Looks like it wasn't the case, it's just that I assumed... Sometimes I forget how references work. Total... It couldn't see total, which was defined there. I guess that makes sense, actually. It's just I always forget what you can or can't do with Python. So I needed to declare total as a global variable. Then it can actually see total because it's not in local scope. That's just one of the things that happens when you use Python, where everything's a little bit fuzzy. And it's not like C++ where you have to be extremely explicit about what is used where and which is referenced where. In Python, you get to take lots of shortcuts, but then that can sometimes bite you later on. Alright. So I have a number. That's right. That was just part 1. Oh god, we have delete directory. Okay. So... Now you're ready to choose a directory to delete. The total disk space available to the file system is 7 with some number of zeros after it. To run the update, you need unused space of at least... What is it? 30 million? You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of used space is that. That means the size of the unused space must be that, which isn't quite the 30 million required by the update. Therefore, the update still requires a directory with total size of at least that to be deleted before it can run. So we could choose a bunch of directories to delete. E and A are too small. So you choose the smallest directory, which is enough. Okay, okay, that's not bad. So I need these numbers, so... Alright, this is the easy change. I say that now, but I mean, we've already got the framework in place, and I don't actually need to delete any folders despite it seeming like I do. I just need to calculate so we do get size root. Ah, okay. Here's what we do. We don't have to say the name of the directory we want to delete. So we can anonymously record the sizes of all the directories, and we don't care about their names. And then once we've actually done that, sizes equals, so sizes dot append size. Now we just have some list of a random bunch of sizes of different folders. We've also worked out the size of every folder. Now we say all right, let's just write all these things. So we've got total. Where's the music stopped? Okay. Total disk size equals that. Let's say free space needed equals that. Used space equals used space equals get size of root. Okay. So unused space equals total disk size minus used space. Getting there. So additional, it's a bit wordy, isn't it? Say okay, more space needed equals that minus that. So basically we have to find the smallest folder which is at least that. Okay, so now we say canned equals, just say that for now. That's how much space we've used. For size in sizes, if size is greater so if size is less than canned, so we found a smaller folder and it happens to be big enough that it would free enough space for us, and size is greater or equal to more space needed, then canned equals the new size. And finally, we just print canned. Alright, that's a bit of a mess. Let's see if this works. 214171. Done. Alright. That whole problem took me about 1 hour, 10 minutes or so. That was my longest yet, but it was a good problem because it actually involved building a tree, and trees are fun. Nice Christmas tree. Nice Unix file system Christmas tree. But yeah, that was a big mistake I made, assuming that folder names are unique, which is... They knew that people would fall for that trap. They designed this on purpose so that there'd be lots of duplicates, so you'd... The only way you can give something a unique name is to include the entire path, starting from / in its name. Which is what you do in real Unix systems. That's what you do, but that's the whole point of having a path. I mean, there's lots of interesting stuff you could extend this problem with. Like, you can have more Unix commands introduced, like delete or stuff like that. Copy. So far, the part 2s have always been very easy. Like, I kind of expecting them, I can't remember what it was last time I did this, but I was always kind of expecting them to be a difficult extension to the problem. Introduce some complex new concept that you have to deal with or twist. But it doesn't seem to be the case yet. Like, this was literally just take a bunch of numbers from what you've already done and just do a bit of arithmetic and get a different result. Simplify chained comparison. Oh yeah. Yeah. All right. Well, tomorrow is just another problem. You can sort of see a picture emerging here. Yeah, so yesterday I actually did the problem the moment it released, and that happened to be a pretty easy problem, so I solved it within like 5 minutes of it being released. That's the only time I've actually been competitive so far. Okay. Well, that's today's problem. Guess I'll see you tomorrow. Maybe I might be busy tomorrow. Let's see. If that's the case, I'll just record it offline. Alright. Oh, my webcam jammed up. What happened there? How long have I been frozen in space? Alright, see you later, DJ.